the next question, right? You can able to see here. So you have 3 bars, right, which is connected like this, shown in the figure. Your Young's modulus is given, cross section also given, right? They're asking you to identify what is the displacement at point 1 and what is the stress in element 3. So only in element 3. So this is the question, right? So it is similar to this. So you have 3 elements, right? And I think I can't use this particular tabulation because you can see that all these elements is inclined. There's no horizontal elements. Anyway, I will use it to fill this 4 nodal points and 3 elements connected to this. First step is you have to locate your coordinate point. Okay, so that is very, very important. So what I'm going to do is I will consider your coordinate point accordingly. So I'm going to consider this is my coordinate point. So which is this is my x-axis and this is my y-axis. So this is 0, 0. So because the data is mentioned related to that, so that's why I'm writing it like this. Okay. In that case, I can identify what are the coordinate points for other nodal points. So this will be 0, minus 600 negative. This is 800, right? So 800, 0, right? And what is this one? This is 450, 0. And this is minus 450, 0. These are my nodal points, right? We'll go one by one. Let me consider the first element. So my first element is like this. This is my element 1, which is connecting 0, minus 600 and minus 450, 0. In my first element. Okay. So what you can do, you can identify. You can identify what is the cos theta and sin theta with respect to that. Okay. So it is up to you. So this is my nodal point 1 and nodal point. So 2 and 1. You consider anything as your first node and second node. So as I told you, so always you consider the left hand side, right, as a first node and the right hand side as the second node. So in this case, what I can do, first node is 2. I'm going to consider the first node as 2. The second node is 1. Okay. So which means this is x1, y1, and this is x2, y2. Okay. So let's identify what is my cos theta. What is my cos theta? X2 minus x1 divided by L. Right? Before that, I have to identify what is my L. Right? So what is my L? So L is root of x2 minus x1 the whole square. So 0 minus of minus 450 whole square. So which is 450 square plus 600 square. So what is the value of L? We are getting, so we are getting 750. So what is cos theta? X2 minus x1 divided by L. So 0 minus of minus 450. So which is 450 divided by 750. So what is 450 divided by 750? 0.6. So L is 750. Cos theta is 0.6. If this is 0.6, surely it will be 0.8. Let us identify what is my sin theta. Sin theta is y2 minus y1 divided by L. So y2 is minus 600. So look here, minus 600 minus 0 divided by 750. So your sin theta is minus 0.8. So be careful with this, 0.8 minus 0.8. So the next one is your element 2. So element 2 is something like this, which is connecting nodal point 1 and 3. It is connecting nodal point 1 and 3. This is my element 2. So what is my values here? So 1 is 0, minus 600 and 3 is 800, 0. So I will consider the 1 as first node and 3 as my second node, which means this is x1, y1, this is x2, y2, right? Apply the formula. What is my L? L is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 minus x1, so it is 800 square. Y2 minus y1, so it is 600 square. So 800 square by 600 square. So 800 square plus 600 square root. So we are getting 1000. Right? So L is 1000 here. So what is your cos theta here? So x2 minus x1. So 800 minus 0. 800 minus 0 divided by 1000. Getting 0.8. So cos theta is 0.8. What is sin theta? Sin theta is y2 minus y1 divided by L. So y2 0 minus of minus 600. So it is positive. 600 divided by 100. Sorry, 1000, which is equal to 0.6. This is 0.6. Okay. So your element 3 is similar to this. So it is like this. This is my element 3, which is having 0 comma minus 600 and 450 comma 0, which is nodal point 1 and nodal point 4, element 3. Right. So what is my L here? Root of 600 square plus 450 square. It's already we identified. 600 by 450 is 750. Right. So what is your cos theta? So I am considering the first node as this one. So x1 comma y1, and this is my second node x2 comma y2. So first node is 1, second node is 4. So you are getting 750 and cos theta. So x2 minus x1. So 450 divided by, so 750, right? 450 divided by 750. So what we'll get approximately it is 0.6. Next sin theta, y2 minus y1. So 0 minus of minus 600. So 600 divided by 750. So 600 divided by 750, you will get 0.8. Right? So these are my values. So now itself I can just I can see that most of them is 0.6 and 0.8. So you know that multiplying this, so just for reference, I'm writing this for reference. Okay. So multiplying 0.6 and 0.8, you will get 0.48. And 0.6 square, you know that it is 0.36, and 0.8 square, it is 0.64. Right? So in substituting, you can directly substitute. Okay. So you don't have fourth node, so that is not applicable. So only these 3 elements. So we identified all these 3 elements. Now we'll proceed with finding out what is my values. So I'm going to look, the question doesn't have any formation of your global stiffness matrix. Okay. If you want, you can cut short that also. So to minimize your time. Okay. So, but if your answer is perfect, if it is right, you will get full marks. Otherwise, you lose some marks because of this, because you don't write the steps properly. Right? When I say cut short, what it means, I won't enter these values. So whatever which is related to nodal 2, nodal 3, and nodal 4, I will cut short now itself. Okay. I will concentrate only on nodal point 1 because these things are fixed. So when it is fixed, you no need to calculate these values, right? That is what I am saying. Okay, right. I think we solved 2 problems. We solved 2 problems by normal procedure. So as a part of knowing this, how to do this, I am going to cut short it and I will show you, right? So, but don't do this when you are not confident. Okay, so because at least you will get some step marks when you write everything. Okay, right. So what I could do, I go for element 1. So element 1 is connecting nodal point 1 and 2. And you see that, so the first node is 2. First node is 2, right? Second node is 1. So you know what is the formula. So what is my K formula? It is A by L C square CS CS square. Similarly, minus C square minus CS minus CS minus S square. C square CS CS square C square CS CS square, and this will be negative. This is my matrix, right? Now itself I will address it. You note that first node, right? First node is like ux1, sorry, x2 and uy2, right? The second node is first one here, which is x1 and y1. So I'm writing it here also, x2, y2, x1, y1. Think about it. Node 2 is fixed. So I will just highlight it. So 2, node 2, node 3, node 4. These are all fixed. In that case, I have no need to write this rows and this columns, right? Which means I can eliminate now itself. So I don't need to worry about this one, this one, this one, and this one, right? I will concentrate only on this part. Okay, can able to get it? So what I'm going to do is when I'm writing it to avoid confusion. So it is connecting to 1 is equal to AE by L. What is my A? A is known, which is 250. So 250 into 1 into 10 power 5 divided by what is the L here? Length of this is 750. 750 x x x x, indicating these things. I'm eliminating it. Okay. So x x x x. These terms are x. Only this c square. So c is 0.6. So 0.6 square is 0.36. So I get 0.36. This is CS. CS is 0.48. CS, so 0.48. And S square is 0.8 square, right? So minus 0.8 square. Sorry, see, I made a mistake. So 0.6 into 0.8, but it is negative, right? So minus, this will be minus. This two are minus, and this is 0.8, 0.64, right? This is my matrix. Address is same. It is x2, y2, x1, y1. So x2, y2, x1, y1. Let me go for element 2. So element 2. I think I have not considered this. Consider பண்ணி நம்ம போடவே இல்லை. Sorry. Oh. What are you getting here? Sorry. So K21, what happens when you add this? So 250 into 1E5 divided by 750. What you are getting? 0.33 into 10 power 3. Right? Are you getting this?
Yes, sir, same.
Okay. Okay. So next, element 2. Element 2 is connecting nodal point 1 and 3. Right? So nodal point 1 and 3. So let me go for K13. So AE by L. So AE is 250 into 1 into 10 power 5 divided by L is 1000, I think so. Right? So L is 1000 for the second term. So look here, when I address it, 2 and 1. So 1 and 3, right? Which means what I will get, I will have x1, y1, x3, y3. Right? Similarly, here also I will get x1, y1, x3, y3. Right? So these are the terms we have. Okay, so you know, so 3 is fixed. 3 is fixed. In that case, whatever you have, I'll put x here. So x, 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 x. So these terms we don't have. Remaining. So c square, cs, cs s square, right? What is my c square? So c is 0.8, 0.8 square, which is 0.64. This is 0.64. So cs is 0.48. So this is also 0.48. And this will be 0.36. You're getting 25,000 or 25 into 10 power 3. Are you getting this?
Yes, sir.
See, there are a difference. So one is 33, other is 25. Right? How to make it as a common term now? How to make it as a common term? What we can do is you take any one divided with respect to the other. Okay, that is one way. I think that is complicated, right? So better you can take 1 into 10 power 3 as a common term and you can multiply this 33 inside, right? So that is the best way. I think so. Right, so we can substitute it accordingly, right? What is the values with respect to this? Okay, I think let us proceed with this. I think again I have to write the same equation, right, for K21, right? So because, yeah, K21, well, I can write it as, okay, let me consider 1 into 10 power 5. No other go, that is easy. So 0.33 I have to multiply inside, right? X, 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 X. So 0.36 into 0.33. So 0.1188. So 0.48 into 0.33. So minus 0.1584 minus 0.1584 and 0.64 into 0.33. So 0.2112. So I think this is the best way. Okay, so here also, what I can do, I can take this 25, right? 0.25. I will multiply inside. So 1 into 10 power 5. Remaining terms. So 0.25. Let me multiply with respect to that. So 0.64 into 0.25. I'm getting 0.16. 0.48 into 0.25. 0.12. This is also 0.12. 0.36 into 0.25. 0.09. Remaining, you don't have the values. Right. So when I go for element 3, you know what is the formula. You proceed. Let me consider what is your element 3. So for element 3, so we know we are going to connect this by using two nodal points. What are the nodal points? It is connecting 1 and 4. So it is connecting 1 and 4. So 1 and 4 is the two nodal points. Is equal to your common term. I think there is no change in the common term, right? So it is AE by L. So AE by L. So L is 750. A and E is a common term. So which means the same data which is for element 1. So element 1 is having L, this is 750, right? Same data, which means this one, which is 250 into 10 power 5. So what you will get, you are getting around 33.33 into 10 power 3. So that will be my common term. So let me write that. So 33.33 into 10 power 3 into your matrix, right? So if I write what is my address for this, so my address will be 1, so which means x1, y1, and this is 4, which is x4, y4. Similarly here also you will get x1, y1, and x4, y4. So these are my terms. So let me check it out. So in this element 3, so this is my element 3, right? Element 3, nodal point 4 is fixed, which means anyway I'll be citing that particular row and column. So nodal point 4 indicates your x4, y4, right? So no need to identify what is the value for this. You can directly substitute as 0. So you know what is the formula. It is c square cs minus c square cs. So this term, this is what we are getting, x4, y4. So this entire terms gets cancelled, right? So which means I will get only this term, c square cs, cs s square, right? What is my c? C is 0.6, s is 0.8, right? So when you substitute it here, so what will get? So we'll get 0.6 square, so 0.6, 0.8 into 0.6. This is also 0.8 into 0.6, and this is 0.8 square. So this is what we'll get. Other things I can just consider as x, because that is a fixed point. So no need to calculate the values and all. Okay, so this I can rewrite it. So what I can do, I'm going to rewrite it is 0.6, right, multiplying with 0.33, so you will get a value, right? This is 0.6 square, right? So I think similar to your element 1. So note, so element 1 and element 4, element 1 and element 3, it is similar. The only thing is there is no negative term here, right? Everything is positive here, right? So I will write this entire element and I will consider everything as a positive. So what I am getting? I am getting this. After multiplying 33.33, what I am getting? I am getting 0.1188. So this is what I am going to get. But in this matrix here, in this location. So I will write that. So element, so K14 will be equal to 1 into n power 5 is a common term. So remaining, so what you are getting? So it is 0.1188. So I'll be getting here. So 0.1188. This is also a positive value, not a negative one. 0.1584. 584, and this is also 0.1584. And the last one, it is 0.2112. 0.2112. So remaining I can consider as x, because this terms doesn't have any data. So no need to identify. This is my table. So let me address this as usual. So this is x1, y1, this is x4, y4. Right? This is my address. So I completed all my element stiffness matrix. Only thing is I have to identify what is my global matrix. We go for global stiffness matrix. We go for global stiffness matrix. So in global stiffness matrix, first step is I have to identify what is the size of my global stiffness matrix. What is the formula? It is number of nodes into degrees of freedom per nodes. So DOF per node. Okay. So number of nodes, if I consider you having 4 nodes, right? Look at the problem. So how many nodes? 1, 2, 3, and 4 nodes. Each node is having 2 degrees of freedom, right? So which means, so 4 into 2, so you're getting 8. So again, you will get an 8 cross 8 matrix. So another 8 cross 8 matrix. Let me assemble this now. So go to the next part, which is capital K. So capital K in terms of 1, 2, 3, 4. I am not going to write that. Right? Let me go for a tabulation. So I need 4 cross 8 cross 8, right? So let me go for 8 cross 8 matrix table. So I have a table here. Right? So this table I can use. I will just drag it and keep it here. So this is also very convenient for me just to type it out, right? So this is the entire table. Is the matrix. This is the matrix. And this is 1 into 10 power 5. So you know what is the address for this? It is x1, so x2, y2, x3, y3, x4, y4, right? So these are my matrices. Similarly here also, so I can write it here. So x1, y1. So similar to that. So x2, y2, x3, y3, and x4, y4. So representing each columns and rows. Okay, so just type the values accordingly. Let me consider for element 1. So element 1 links with what? X1, Y1, right? You can able to see here. So my address is at X1, Y1. So this is my X1, Y1 location. So this is X1, Y1. Similarly, this is also X1, Y1. So write this in X1, Y1. So 0.1188. So this thing, right? So 0.1188. So this things you will be writing it here. 0.1188, right? And y1 is maybe getting 0.1584. This is also same, right? Which is 0.1584, and this is 0.2112, right? We are getting these values. Okay, so first element is over. I'm connecting my first element. I'm addressing based on the address. I'm just put that. The second element, that is also you can able to see is related to x1, y1, right? So it is 0.64, 0.48, 0.48, 0.36. So which means, so here itself I write plus 0.64, this plus 0.48, this plus 0.48, and this is plus 0.36. Third element, that also comes under x1, y1. So 0.1882, similar to the previous one. So I put into 2. I put into 2. And if I put equal to, automatically we'll get the answer. So that's why I'm doing that. So into 2.
So for first
So
element, it
this
is
is my,
minus 0.1584, right, sir?
sorry. Oh, sorry.
For
Yes,
first
yes,
element,
thank you. So this one, right? So which means this gets cancelled. So you look here, the first one, it is minus 0.1584. Third element, it is plus 0.1584, that gets cancelled. So which means you don't have this data. So you have only 0.48, right? So you have only 0.48. So this is also only 0.48. So remaining I can put x. So sorry, I think the table is changed accordingly. It is not fitting properly, right? So whatever I entered, so okay, let it be, right? So the other things is x. So which means you are going to cancel that rows and columns. So only this thing is enough. Other things you can leave it out. Okay, this is my global stiffness matrix. Okay, next let me go for force matrix. So what is my force matrix? So my force matrix should also be 8 cross 8 matrix. So which is including, it is including x1, y1, x2, y2, x3, y3, x4, and y4. Just look at the problem. This problem has only one force that is also acting downward, which is y direction. So in nodal point 1. So the other things is 0. So which means minus 18 into 10 power 3 will be in y. Okay, so where is y here? In this y1. So only in this data. So minus 18 into 10 power 3. Remaining all 0. Right? No need to worry. Okay. So now I can put F is equal to K into U. F is equal to K into U. Right? So my concentration is only on this 3 terms. So this 4 terms. X1, Y1, X2, Y2. right? So only on this terms, right? So not on other terms. So other things you no need to worry because it is getting cancelled because of the fixed support. So we'll directly write down. So your F, I will write only that which is 0 minus 18 into 10 power 3, 0 and 0 is equal to 1 into 10 power 5. This will be 0.8776, 8776 and 0.48, 0.48 and 0.7824, 0.7824. So into, sorry, I think, yeah, this is also fixed, right? Sorry, but confused a little bit. So, okay. So in that case, so this itself actually you have only two, right? And this also will have only two, right? Sorry. So what is, so you have only nodal point at nodal point 1. So look at the problem. You can able to see that only nodal point 1 is having displacements. Other nodals are all fixed. In that case, you have only that first node, which is ux1, uy1, right? Remaining is all 0. So I think only this x1 and y1. So no, even not these things. So you don't have these things. Okay, so only x1, y1. So in this, all these things. Okay, so that's why. So we will have something like that. Okay, right. So now we got this equation. So only thing is I have to solve this equation, right? So let me simplify this. So 0 is equal to 1 into 10 power 5. So 0.8776 ux1 plus 0.48 uy1. Which means what I will get is this will get cancelled and you will get ux1 is equal to 0.48 minus 0.48 divided by 0.8776 uy1. So this is a term you will be getting, right? So after substituting these things. Next, you will get another term which is minus 18 into 10 power 3 is equal to 100 10 power 5, 100 10 power 5 into 0.48 ux1. So 0.48 ux1 plus 0.7824 uy1. 0.7824 uy1. So that's it. So now you substitute this in this equation. Try to substitute it in this equation and find out what is the value of ux1 and uy1. So what is your ux1 and what is your uy1? Tell me what's your answer. So this is 0.1722 mm. Okay.
The other is minus 0.0942.
0.0942.
Both are minus.
Both are negative. Okay. This is also negative.
Yes, sir. Yes, sir.
Okay. Okay. Thank you.